Welcome everyone to the September 18, 20, and 22nd of 2023 installment of the Cyberbot Educator Workshop. I will go ahead and copy in a link to this slideshow. Make sure to hold on to it because it has a lot of links that we'll be following, and I'll be I'll be following a lot of links. And so if you have this, you'll be able to get back and follow those links as well. Let's see here, chat. And paste. Okay, so it should be there in the chat for you. Go ahead and open it, but you won't need to necessarily follow along, although it can end up being helpful if you want to dwell on an earlier slide while I'm plowing ahead. Now, in your Zoom workshop, typically it comes up filling up your entire screen. If you only have one screen and you don't have another for opening your editor and maybe a web page or two, the thing to do would be to click this view link. You'll see a view link in your upper right, and then you'll end up choosing exit full screen. And then that way you'll have Zoom as a window. And what you can do with that is you can take the window and you could, so here's an example of the Zoom on the left, and then you might have your editor open on the right. And so I'd like everybody to get their desktops situated so that we can all do some hands-on stuff without Zoom covering the editor. And so something like this, if you have a single monitor. If you have a second monitor, just go ahead and put the python.microbit.org/v/3 editor onto another screen. Otherwise, tile it, and I'll go ahead and paste that link in so you can get that started as well. There it is in the chat. With you today are the Education Department. Ari Alvarez is Parallax Vice President. Stephanie Lindsay is Documentation and Product and Documentation Manager. And then that's me, Andy, on the left. And let's talk a little bit about what we're going to do during this workshop. I think just really to summarize, what we want to do is take looks into a number of different parts of the curriculum we have available, and also do some of the most important items to make sure that you've had the hands-on experience with that, and also that you know where all the resources for both the students and the teachers are. Today, we will be focusing on making sure we've got our microbit connected while the workshop is running. And we're going to also double check, make sure the Cyberbot module is added to the project. We'll connect it to a Cyberbot board that's in the kit you have. And we're going to, instead of calibrating servo motors, we're going to be testing them just to see how a script we write ends up translating into motor speed and direction. And between today and Wednesday, we'll have you build up your Cyberbot, and not listed here, we're also going to have you make sure you can log into learn.parallax.com either by being given a new login or by remembering your old login if you already had one, and we'll have you join cyber.org as well. Both of those logins will give you access to teacher resources that we'll talk about on Wednesday. Then on Wednesday, we'll focus on navigation with the robot and get started on touch navigation. Well, we also have a distinguished visitor from cyber.org. That's going to be Linda Morgan, and she's going to tell you about the teacher-driven educational resources that are available through cyber.org. And then on Friday, we'll continue with Cyberbot robot applications. We'll hopefully do infrared navigation and learn about a lot of the other applications that are there for you and the students to experiment with. And then we'll talk about, let's see, we will also look over some of the applications, a few quick videos of some of the applications that we won't have time to do during the class because they're really cool. And I encourage you to try them later. And then again, we're going to focus on a few important things. And when you come away from this, you'll probably be thinking, gee, there's a lot more there. I think I've got some studying ahead of me, but you will have, our goal is to make sure that you come away with the main points and some important skills and prior experiences. We encourage discussion. Feel free to unmute yourself if you want to jump in with a question. You can also just send a chat and Stephanie will bring it to my attention. If it's something that she thinks that it should be answered as the group, otherwise they'll answer it directly through the chat. And make sure to remute yourself when you're done so that we don't have lots of background noise. All right, so the Cyberbot robot was partially underwritten and co-developed with cyber.org. So Parallax, which is where we're broadcasting from, and cyber.org worked together to create this. Cyber.org has been around for over 10 years. They're funded by the Department of Homeland Security, staff of approximately 25, and their goal is to create a cyber-ready workforce, and they have lots of great resources for you that, again, we'll be talking about right around 4 p.m. Pacific time on Wednesday. Chip Gracie is the founder of Parallax, and Ken, his brother, is our CEO and runs the business side of things, while Chip does all the great inventing. This is a picture of our building. I'm actually behind the window just to the left, not shown. And Parallax has around 20 employees. We've been around since 1988 and started doing educational materials in 1997. A little bit about myself. My main background is in electronics, but for over 20 years now, I've been working on imparting knowledge of electronics, programming, robotics, and many other things, as well as designing kits for education and sometimes even hardware. The main thing that Parallax has always done is provided resources for designing inventions. That includes, and mainly, the programmable brains that you find in normal products, as well as in some pretty crazy product prototypes. And so we support both the brains and many of the subcircuits that you'll find in these kind of prototypes and products. Parallax made its first big splash with the Basic Stamp microcontroller. This was in the 90s, and before this, it usually took a fair amount of technical background. Either trained electronics technicians or engineers would be the type of folks that would be putting programmable devices into circuits. Now it's a very commonplace thing, and the Basic Stamp was the first step towards what we're doing now, which is very commonly using microcontrollers in education. The Bobot robot was the first robot that we came out with that had a Basic Stamp and an area for building circuits, and so you could write programs for the Basic Stamp, and then the Basic Stamp would control and monitor the circuits that you built and roam either without circuits or in many cases with sensor circuits. And And so this became a very popular platform because it reached many different parts of STEM, especially the programming and scripting parts. And then we have circuits, there's math, there's science, and it all comes together into a robot, and students get excited also with making things move when they write their code. And so every time a new microcontroller came along that that became popular, we would build a robot and a curriculum around it. Now, most recently, the probably the most popular microcontroller in education right now is the microbit that we'll be working with today. It's kind of a microcosm of a cell phone. It has a little display. It has a touch interface, a couple of push buttons here. It has a built-in microphone and also a little touch sensor. Also built into it is a radio for communicating with other microbits, and also Bluetooth with computers, a built-in compass, accelerometer for tilt and motion sensing. It can sense temperature and light as well. So lots of really great stuff with the microbit. And so what we did was we set up a robot where you can plug the microbit into the robot. And this ought to look familiar and kind of like that basic stamp version that we looked at earlier. And essentially all the same lessons travel through all the different robotics kits for the most part, since the microbit has some extra capabilities that don't that you can do stuff like radio communication with other microbits and tilt sensing and all that without buying any extra parts. There's a lot of extra activities that come with the microbit Cyberbot that that would otherwise require additional parts with the other robots we have. As for where to find student resources, that's going to be at learn.parallax.com, and I'm going to copy that link and paste it into the chat for you. And then the teacher resources are here, and we'll be talking about those later this session briefly, and then we'll take a closer look on Wednesday. There's also, if you need to ever purchase a Cyberbot robot or a microbit, here is the All Things Cyberbot page for purchasing. And then here is the All Things Microbit page for purchasing, both at parallax.com. We also have some upcoming workshops. If you're interested in a very microbit for teachers who have never worked with the microbit before type of course, there's a 2-hour workshop on November 13th. And then we have another one on February 24th, and then another Cyberbot workshop coming up in late March of next year. All right, let's talk a little bit about the homework. Most importantly, it looked like you all did a really good job on it. And so well done there, folks. I just want to mention that on this slide, we have links to all the homework, and especially for those of you who are working along from a video recording of this as opposed to right here, right now. These are links that you will want to complete before you start following along with these videos. So first off, there'll be a kit that you'll need to have, and that's the Cyberbot robot kit, which looks like this. And then there will be a series of videos with matching instructions that you'll end up doing. And that will help you get familiar with the Microbit Python editor version 3. And so each of these activities, there's 5 of them, they have videos that run from 1 to 3 minutes, and then also the instructions are written down below each video. And so you'll do a video. I recommend just making liberal use of pause and play, and then going along with the steps in the video. But they are listed below the video. And then here we have a second video and a second set of steps. Thirdly, you'll need some materials, and I'm hoping we all have those gathered for today. I went ahead and put them in a separate Google Doc. They were in an email, but here they are. And so primarily you'll need alkaline batteries. And let's see here. So you'll need your Cyberbot robot kit, including the microbit that's in it and the programming cable, the USB cable that's in it. You will also need some kind of things for sorting. So paper bowls are nice. Nice big paper plate is also good. You can just upend the kit and its parts onto a paper plate, and that makes it easy to look around for stuff. Some of the parts are pretty small, and so you will also need a magnifier, which I accidentally set aside. But okay, so here is my magnifier. Usually a cell phone makes a really good magnifier, and this will be nice for identifying small parts in your kit. If you don't have an app already and are hesitant to install one, you can also just use the camera and typically pinch and unpinch to zoom in on small parts. And then last but not least, we did some homework, and that looked like this. So this is a document, and it basically points to a number of learn.parallax.com tutorials that students will go through, and I recommend for you to go through them as well. Since we're doing this during the work week, what I did was I tried to make it short and sweet by just selecting a particular section from each different topic. And so scrolling text will take you to the beginning of a learn.parallax.com tutorial on the LED matrix of the microbit, and it has more pages that you can go through. And when you and students are going through these, the recommended approach is to take this kind of tutorial page and then have it either on one screen or on one side of your screen, and then have your microbit editor on the other side of the screen, and actually hand type this stuff. It's the best way for things to sink in, is if you basically can say, okay, well, gee, I see this from microbit import star, and you don't have to do this right now. We'll have lots of code that you'll be entering, but for the moment, you might end up just typing this last line here of display.scroll hello. And then you'll end up trying out the script. And by the way, if you have not plugged in your microbit to your computer, do that, because we will be running some scripts pretty soon. So make sure to get your microbit plugged into your computer. So even though the homework just had a little short example, there's lots more modifying of that short example. And then there's also pages about images, either pre-made or custom. So there's a lot more material there that I didn't have you go through. And I just want to kind of bring to your attention that yeah, these are just excerpts. And most importantly, if you're feeling in need of some kind of Python book or tutorial, well, you have it here at learn.parallax.com. The programming basics are in these chapters. And again, if you're hand typing in the examples and reading the explanations and trying stuff out, trying adjustments to example scripts, you're going to learn it really well. And that's what we hope your students do. The students also are challenged to do some stuff that answers are not provided for, but that you will have access to. And we go through communication, recollection, calculation, decision, and then repetition. So these are some of the basics. And then in addition to that, there's some programming habits like keeping comments on what your script is doing. And then it also talks about push buttons, writing functions, and different kinds of variables and their scope, as in where a variable might end up surprising you because it might contain a value you're not expecting. All right, so main thing, there's a lot of material here, and the whole entire Cyberbot tutorial series is right here. And each of these tiles represents a chapter in the tutorial series. And the word we use in-house in web speak is not chapter, but you can think of each of these as a chapter. And then within each chapter, if we go to writing microbit programs, which is where you were in the homework, you'll see activities listed along the side, and you can either navigate forward and backward page by page, or you can navigate by clicking a particular activity in the contents along the left. And then if you want to get back up to the top, you can just go to Cyberbot tutorial series. And I should paste this one in. There we go. All right, so that was the homework. And
I have a comment on the homework.
Oh, yes, go ahead.
Alice is sharing, she completed her homework and saved the assignments to GitHub as a way to reshare the content. And she had tried using the MakeCode editor versus the Python editor because the Python editor requires downloading rather than saving to the cloud. And the classroom computers are really locked down, but that didn't work using MakeCode. So.
Okay. And off the top of my head, I don't know how to help with that. But yeah, I'll look into that. There might be some way to get it done, especially since MakeCode and yeah.
Saying it didn't work using MakeCode, I'm thinking they're probably talking about the robot.
Okay.
I'm not quite sure. Maybe we can clarify that, talk about those options later on in the course.
Yeah, that sounds good. And we will have a little bit of time after the 2 hours is up to talk about things like that too. Okay. So here is a, let's see, I want to basically paste this in to have you guys try out with your own microbit. So on slide 25, there's a nice long program that kind of summarizes everything we've done. And what I'm actually going to do is do one copy where we've got the script. Need to paste it to you as well. So here is the script for you to try out. And so for you folks, don't worry about pasting it into 2 editors. I'm just pasting it into 2 editors for demonstration purposes. So I'm going to run it on the editor on the right, and then I'll point things out on the editor on the left. So here we are flashing that into the microbit. And after doing so, it should, if you hit show serial in the lower right, it should show you a prompt. And of course, for me, it's not. So the first step I'll do is try send to microbit again. Okay, so that didn't work. So the next thing I'm going to try is pressing and releasing the reset button on the underside of the microbit. Okay, so here we have the microbit. Turn it over, press and release that reset button. And with that, notice that now it displayed the press enter to continue message. And I've noticed that sometimes that has to be done in order to get the terminal to work the first time, and then after that it works like a charm. I don't know why that is, and I don't know if it's happening for everybody. But yeah, that reset button on the back of the microbit will get the text to appear if it doesn't appear. Another thing is there's 3 dots in the upper right of the serial monitor, and you can click those and then select send Control D to reset. Now it'll seem like things freeze up when you do that, but it's just because it's displaying a message that it restarted. And then if you hit send to microbit, that's another way to get the code to come back and display on the serial monitor. All right, so once it displays, let's take a look quickly at what it's doing here. This is using the serial monitor, so it's using print to display messages and input to get messages that you type. So it prints hello, so there's hello, and then it says input, press enter to continue. So I'm going to click next to that prompt and press the enter key. And what's it doing now? It's displaying 2.5, 1.414, and the letters TEXT or text. Well, that's from the recollection or remembering part of the tutorials where we set some variables like A, B, F, and T to things like 2, 5, 1.414, and text, and then printing all those out. So this is the storing part, and then it has to recall them in order to communicate them to you. Pressing enter again, C equals 7. Well, C down here is equal to A plus B. And A was 2 and B was 4. So that works for me, or sorry, A was 2 and B was 5. And so the fact that C is 7 definitely works for me here. Hopefully for everybody else too. Press enter again, and then it's going to go through some decision. Now remember, A is 2 and B is 5. So here we say if A is greater than B, print A is greater. It's not going to do that because A is 2 and B is 5. So then otherwise, if B is greater than A, print B is greater, and that's what we expect. I'm going through this quickly because we did this all for homework. But please do jump in if you have any questions. Pressing enter again, it counts to 10. And that's because we have a for loop here. And, oh, pardon me, it counts to 9. That's a funny thing about Python. For a lot of higher level counting applications, it's a really good idea to include the first thing in your range, but not the last. And so, so as a beginner, it's a little tricky to get across that, hey, this first value is where you start, and it's inclusive of that, but the second value is just before where you end. It's not the final value. So you count up to 1 minus that, and notice that notice that there's an index named n here. And so each time through the loop, first time n is going to be 1, second time it'll be 2, third time it'll be 3, and it keeps on checking to see if n has become larger than 10. And after the 9th pass, when it tries to do the 10th pass, it then says, oh, well, it's at 10, so we're not going to do it. We're not going to do these statements. We'll just skip back out of here. And then just a reminder that if you have either a decision like if A is greater than B, when that's true, whatever statements have to be done need to be below and indented. And the next thing that's not indented is what comes next after we're done with doing whatever the script does, if that's true. And then that also applies for counting loops, that you have to have the things that are going to be repeated a certain number of times below and indented from the for loop. Okay, so what's coming up next? What's coming up next is that n is reset to 10. And this had to do with a tutorial that we that we skipped that talks about local versus global variables. Here we just kind of came up with n. Let's see, actually, yeah, n has not been seen before. So the Python runtime says, oh, well, I'll just set aside a variable named n, and we'll use it, but only for this for loop. And then we'll forget about it completely once we're out here. At this point, n becomes a global variable. And so anything in the script after that that uses n will resume at 10. And so when I hit enter, we want to see it start counting ones per second from 10 onward. And there we go. Okay, so that's a super roller coaster quick review of basically some of the basics that that we had you go through, or at least take a look at. And it depends if you've been programming with Python for a while, then it's maybe only worth a glance. If you're brand new to it and feeling unsure, then it's going to be one of those things where you want to set the tutorial and the editor side by side and start typing in stuff to get familiar with it. And also do this in metered times. Don't feel like you have to spend 10 hours to go through the whole thing at once. That does work for some people, but I usually try to do it in 30-minute slots. 20 to 30 minutes, and then move on to something else. All right, so another thing and these are, I want to emphasize that these are resources for the students that we're looking at right now. Cyber.org will be talking about some of the teacher-led resources. So these are student-led resources, and this one specifically is available from microbit.org. And what this is kind of a, we're rewinding a little bit here. So I'll paste in a link to Step Counter, and we'll take a look at Step Counter. And yeah, and there's no wrong answer with microbit.org about cookies, because they don't track your personal data. It's just website cookies. So here we are at Make It Code It. And what this is, I'm going to try to back up a little bit and show you Make It Code It. This is sort of a hands-on, experiential way of doing those same kind of lessons that we just talked about, where it's the basics. Like here we have a heart display. Here we have two different displays that are repeating over and over again inside an endless loop. So that's an example of the repetition part. Animated animals, you can use, I don't remember, but I'm pretty sure, animated animals may just be more display, but by the time you get to a motion badge, the A button results in a smile and the B button results in a frown. And that is the kind of thing where it's using conditionals, the if statements that you tried out on the serial monitor. So this is just another way of learning these things. And it's kind of a step-by-step trying it out, but not thinking about it quite as deeply as the chapters that you tried examples from. One thing though is that with the step counter, by the time we're down to here, these are applications of earlier stuff, and what you have is the option of doing it in make code, and this is a program by tiles kind of language, and then we focus on Python for the Cyberbot robot, and so basically there's two tabs. So when it has the code, just remember to click the Python tab to get to that lesson. And here we have everything put together. We've got communication with display.show. We've got calculation with adding one to a variable named steps. We have decisions with the accelerometer if it detected that it was shaken. And then we have repetitions in terms of repeating constantly over and over again this whole thing of checking for an accelerometer shake and then updating the display. So I'd like you guys to try this one out. I'll go ahead and copy it into the meeting chat and go ahead and paste that into your microbit editor. And then hit send to microbit. And I want to emphasize that here you won't see anything on the serial monitor. You can go ahead and hide serial. And what we'll do instead is we'll take a look at the microbit itself. And it won't show anything right away. But if you give it a shake, and I'm in a very brightly lit room right now, and so the camera isn't picking up the numbers very well because they naturally flicker at a frequency that's faster than the eye can detect, but it does show on the camera as this kind of weird scrolling, but you can probably see that what it's showing you is the number 1. And then if you shake it again, we're going to have the number 2 displayed. And then for you, that 2 should be nice and clear. It's just, again, it's an artifact of the video camera, which is why it doesn't look so great on the screen right now. And then as you keep on shaking it, it keeps on. Now we've got 3. And shake it again, and you've got 4. So there's a step counter. There's also nice things like a countdown timer that use all the basics. And let's see here. And that was mainly what I wanted to show you, is that there's this nice organic, fun kind of icebreaker way that you can get the students started on the microbit in the language of your choice with lots of fun stuff. Like, for example, if you wanted to focus on activities that have Python, you can filter that way, and it'll show us 82 different options. And then we can do stuff like maybe focus on music, or we could focus on the radio or the push buttons for conditionals, or the built-in radio. And then, yeah, so there's lots of fun projects, and I do recommend looking at this as a way to get warmed up with the microbit. And the lessons are kind of lightweight. Usually what they do is they give you a little video of what it's about, and then they'll, of course, give you a code example, and then they'll challenge you and the students to improve that code example in one way or another. All right, so there's this is some links to a workshop where there's more general microbit and all about the BBC microbit resources that are at microbit.org. And that's going to be replaced with the Microbit for Beginners workshops in future slideshows. So that was one that's coming up on, let's see here. That is coming up on November 13th. And that's the kind of thing that we'll be talking a lot more about in that workshop. All right, so where was I? Yes, I need to skip a bunch of slides now. And what we are going to do next is build and test our Cyberbot robot. Now, I guess I maybe got ahead of myself a little bit because I did want to show you a few things before we start building and testing it. One is that we have a Cyberbot board. This is what we'll be connecting the Microbit to, and it's got features like right here. There's a power switch. This is the socket where you insert the Microbit. There's a battery power jack, and you have to have batteries plugged in and the switch set to 1 or 2 in order to have a script that has the Cyberbot module added to it. It won't work until those 2 conditions are met. And so the next thing I'd like you all to do, and make sure you're not working on a metal surface for this. At least put a clipboard or a piece of paper underneath your Microbit and board if you have some kind of metal desk. And so all we have to do is make sure we've got our Microbit and serial cable, which I'm sure you do already, and then just go into the box and grab the Cyberbot board. You can, better, let's be safe. Let's go ahead and unplug the Microbit from the USB cable before plugging it into the Cyberbot board. And then after that, we're going to grab some servo motors and put those together as well. And just a little thing about the Cyberbot board. Basically, the Microbit communicates with a microcontroller that's underneath the Cyberbot board. And then that microcontroller actually does additional tasks like runs the servos and controls lights on the board and will communicate with circuits that you build on this breadboard prototyping area right here, this whiteboard with lots of holes in it. And then let's see, we'll need to, I think I'm going to go back to that because we want to check and make sure that, that everybody was able to follow along with the instructions to plug in their Microbit. So we'll do that right now. Go ahead and unplug the Microbit from the USB cable, and then go into your Cyberbot robot kit box. And the Cyberbot board looks like this. And go ahead and take that out of the gray anti-static plastic bag.
Andy, we have a question. Do we have access to the I2C address?
Oh, okay, yeah. So for anybody who didn't understand what that question means, don't worry about it. It's advanced. There is some access to I2C. If you go underneath the board, let me see if I can find it.
Yeah, I mentioned it in the diagram that you showed, so that's why it's there.
Yeah.
Sorry.
Ah, yes, here we go. I don't know if I can zoom in close enough on this or not, but let's see if we can get this.
I love the emoji with the monocle there.
Well, it's clear as mud, but it's these 8 sockets right here. And there's going to be a ground socket and then it's going to be SCL and SDA in very fine print next to those sockets. And again, most of you don't worry about it because it's a very advanced question. The I2C interface is a type of communication that goes between the microbit and this microcontroller right here on the underside of the Cyberbot board. And I2C allows you to add different devices and communicate with them. And yes, it will work if you add those using those sockets right there. You'll need to solder some kind of, or I typically solder a couple of wires to those sockets and then jump it over to the breadboard up here, and then put an I2C device on there, and then yes, they'll communicate. Okay, so here we are with our board, and then once you've got it, you want to make sure that the microbit plugs into the socket. It needs to go deep enough so that a little less than half of the circles are visible. So I'm talking about these circles right here. You want them to be just over half covered, and that way you'll know that you've plugged it all the way in. And once you've done that, you might want to put the power switch, which is right here at the far left 0 position, and then go ahead and plug the USB cable back in. Okay, so let's see here. How are we doing on that? Can I get some thumbs up and thumbs down? Okay, I've got some shakes, so some of you are still working on it. Some head shakes.
It was a little tough at first. I'm like, I really hope I don't break this.
Oh yeah, and it's okay.
I'm sure these guys aren't going to be happy with me if I break this.
Yeah, I don't think you'll break it, but it does take some pushing. I don't know, you might have heard it kind of click loudly when I inserted the microbit on the camera here in. And then let's see here. Getting some thumbs up in the chat. Excellent. There's also a reactions button that you can use. Let's see here. Where is reactions? Yeah, there's reactions, and you can do hand gestures over. Oh, there we go. We got some thumbs up. Cool. Thank you.
And some who've already built theirs.
Yes. Good job, everyone. Okay. Give me a shout out if you need another minute or are stuck. Otherwise, I'm going to continue onward here. So what I'd like to do now is give you a link to, I know that y'all made a pre-made Cyberbot template hex file. This is Cyberbot template with blinky lights. And so when you go to this address, which I'm just about to paste into the chat, what it's going to look like is not very accommodating initially. When you paste and go to the site, it's just a Google Drive that doesn't know what to do with a hex file. And yeah, you'll want to hit the download button. So when you follow the link from your chat, hit the download button. Okay. And then careful not to click it directly. You'll want to go to your downloads either by pointing at it and clicking the little folder, or by opening your file browser and then going to downloads. Boom. And then look for Cyberbot template with blinkylights.hex. Now, once you've found that in your downloads, what you can do is you can hit the open button on your microbit editor, and it should plop you into downloads, and which it might not have for me. So I had to hit downloads and then Cyberbot template with blinky lights, then hit open, and then say, okay, you can replace it with the thing I'm trying to open. And your script should look like this. Where is the link? The link has been copied into the chat. I'll paste it in one more time. Oh, you know what? I apologize. Yeah, just a peculiarity of Zoom. If somebody chats me directly, it causes me to reply to them directly, and I didn't realize that it had switched to that. So I just pasted it in for everyone. And so now, again, follow the link. When you get there, click download. Then open your downloads and, or pardon me, then use the open button. Now, another trick you can do is if you use your file browser, you can actually, like, I'll refresh this. You can use your file browser and just drag and drop from downloads onto your editor, and it'll open the script that way too. Now, once you've got that script open, just go ahead and hit send to microbit. By the way, if you get tired of seeing these messages, go ahead and hit don't show again.
Andy, we don't have access to that drive.
Ah, cybersecurity. All right, let's fix that. Sorry, folks.
Change that to anyone with the link.
Yes. Share. Yeah, it's restricted. Anyone with the link.
Thank you.
Done. Okay, I just hit the done, so try
Done.
downloading now. I'm so sorry, everybody.
Okay. And then I have a question. What do I download? Which one?
Okay. So on the downloads, when I paste in, so I'll paste it in one more time.
Ah, he got it.
Okay. So
Okay.
once you follow the link I just pasted in, basically you'll see a black screen that has a download button. So then you can download it from here. Once it's in your downloads, then you can either, with your Python microbit or microbit Python editor, you can use the open button in the lower right, or you can use a file browser, go to downloads, find the file, and just drag it and drop it onto your Python editor. So here's the drag and drop version. I'll go ahead and refresh. And then hit the open button. Find Cyberbot template with blinky lights and hit open. And once you've got it open, hit send to microbit. Make sure to select your microbit again. And then take a look at your board And what you want to do is set the power switch to 1 or 2. And I kind of got ahead of myself because I forgot to tell y'all to get the battery pack out, put batteries in it, and plug in the battery pack to this barrel jack right here. So let's do that next.
When we download it, are we supposed to get like a long string of code, or are we supposed to open, like, is it supposed to open something?
Okay, that's a really good question. When you download it, if it doesn't, it sounds like, have you got a Mac by chance or a Chromebook? Sounds like it
No.
did it.
I
Okay.
have a ProBook, Windows.
Oh, well, right click that download link and select Save Link As. Bring this back up here.
I wonder if it's getting overwhelmed.
No, what's happening is when I hit downloads or download, it just defaults to downloading the hex file. When
Oh.
she hit download, it tried to open the hex file in the page.
Oh, I see.
And so like maybe if I don't know,
It's a,
what about this one up here? What happens if you hit the little downward pointing arrow in the upper right? Does it work any differently? Because all we want to do is go
You
ahead.
want it to open with what?
Well, we don't want it to open with any. We just want to have it land in your downloads folder.
Okay,
And-
it's in my downloads folder.
Okay, now to
Yeah, I
err
have-
on the side of
problem.
caution, use the open button in the lower right of the Microbit Python editor. So when I said to drag and drop it, I didn't account that possibly some computers might try to open that file. I think what you're seeing is like if I have a blank page here and I drag and drop the Cyberbot template with blinky light, basically you will see the actual native code that the microbit speaks. So these are hexadecimal codes that define the script and the runtime, and we don't want that. So normally if you have the Python editor here and you drag and drop it, it'll open it. But for some folks, it might result in those hex codes being displayed instead. However, if you have your python.microbit.org editor and you hit the open button, then browse to and select Cyberbot template with blinky lights and then confirm the open, that should correctly open it without any hex codes being displayed.
will that work for a Mac as well? We have
Should work for,
questions.
yes.
Okay,
Yes,
so
that should
opening
work for everything.
opening it through the editor is best
Yes.
once you've gotten the file to your computer or local drive.
Yeah, I was just kind of trying to throw out a pro tip here there, but it backfired. Okay, has everybody got that open now? Thumbs up. Oh, some head shakes though. Okay.
Isaiah is saying, I'm on a MacBook. I don't know how to open.
Um,
I'm on a Mac as well. So Isaiah, do you see if you go into your Finder and look in your downloads to see if the file is even there? Do you see the file there? It's reads Cyberbot template, blah 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 hex. Okay, you see that. All right. So then go back into the pythonmicrobit.org and select open.
in the lower right here.
Yeah. When you select open, make sure your downloads are selected and you should see it's a blank sheet of paper, but it reads Cyberbot template ... When you click on that, it'll prompt you to open your blue open button should appear. Click that and then, okay.
So it's
So
similar in
open is
Windows.
the purple
It's-
button at the bottom right. Yours isn't running, mine is fine. So when I hit, okay, for the Mac users, okay, Isaiah, good, you found it. Okay, you found open. All right, so when you click that blue open button, it's going to ask you like, okay, what's the name of like your device? And you'll just choose the only device that should be attached to your computer. All right, who else was having trouble? Marcy. You
So
When
said,
we
although this
do
is not,
download and open it, what should we see?
although this is not, oh, okay. So to that question, I'm going to cancel out of this and zoom back out.
a sheet of paper and the name will be Cyberbot template. So it's this empty sheet of paper. And it's cyberbot template dot hex.
Yeah, so typically it resembles this what I'm showing you in Windows.
Mhm. Just select your
well,
downloads. Make sure you've chosen your downloads option.
Yeah, so downloads should be even in Finder in Mac, downloads should be in the left column.
Yes, Isaiah. Yeah, it's the same thing. With blinky lights, yeah, that's at the end. Marcy, how you doing?
So I'm okay.
Oh,
I
Carmen.
can see mine also. However, I cannot open it with some restrictions from my district.
Oh,
Okay, so we'll have to have you that's yeah, I'm now yeah, I was hoping to weed those kind of problems out with the homework. I don't know how you made it through the cracks, and I'm really sorry about that. Go ahead and watch on. And between today and Wednesday, try to get your district to let your Mac. Yeah, we'll have to talk possibly after the workshop or between this and the next, if it's not letting you either did it not let you download or did it not let you open?
It didn't let me open. I can see it. I can see it. And when I click on it, it just says look for an app in the Microsoft Store. And then we are just completely blocked from that.
Okay, so, and that's when you click this open in the lower right of the Python editor?
Say it again.
Okay, so you have the Python editor here. It's this window on the right.
Correct.
Okay, and so when you hit the open button in the lower right, is that when you see something that says go to the Microsoft Store?
Correct.
Okay. Yeah, we will have to.
Let me try again. That's all right. Let me try one more time, okay?
Okay.
So
All
I
right.
have a question.
Go ahead.
So my screen matches yours. I'm on the Mac, got in everything. I guess when I tried to refresh or run the simulator, there's nothing happening. Is that?
That's correct. If you try to run the simulator does not know how to deal with another physical device. It can't,
Okay.
yeah, it can't say, oh, I know everything about the Cyberbot board.
Got you. Got you. So I'm okay then.
All right, good.
I think I'm a little behind on your instructions that you said that we need to put in the batteries and
Well, no, we're all together on that one. So the next thing to do is to search. I'll go ahead and pull out the battery pack here. Just give me a second. It's going to be in the bottom of the box where you have your Cyberbot kit. And so here is the chassis, and it's got servos, 2 servo motors and a battery pack. So if you take it out of this bag, set the servos aside temporarily. And the battery pack is what you'll need to plug the 5 batteries in. Careful to get the flat part of the battery, the negative terminal against each spring.
Hello.
Yes.
Right.
Go ahead.
I never did get the file itself to. Every time I tried to open it, I kept getting it isn't currently working with Google. It never did download for me at all.
Interesting. Okay, and then you have a Mac. One more thing you can try is to just
I have
okay.
a Windows PC. I have Windows. I don't have Mac.
Oh, you have Windows. All right. Well, for Windows then, and this will work for Mac as well. So if we, let's see here.
When I click on the link itself to go to the drive, it comes up. It comes up and says, blinky lights, hex file, and then I get it open with. If I click download, nothing downloads. It says this server cannot process the request at this time because it has malfunctioned and should be retired.
Try refreshing the page.
Okay.
And then let me see if it lets me right click either of the, no. So, so try after refreshing, try hitting the download button again. Which browser are you in? Are you in Chrome or Edge?
I'm in Chrome. I tried it in Chrome and in Edge.
Okay, and you couldn't get it to download either way. That's interesting. All right, so were you able to create the Cyberbot template from your homework? There was a Cyberbot template that the homework guided through creating. Because what I can do is just paste the text code. It's just that you'll have to go through and add the Cyberbot module. So basically, remember the part where you said project and then you added cyberbot.py?
Yep, I got that.
Okay, so if you have Cyberbot template already in your downloads, just go ahead and hit the open button. And this goes for everybody who did not succeed in downloading that pre-written hex. Go ahead and open your Cyberbot template, the original one. And hopefully that'll come open for you, and it should resemble this.
And open that in the editor.
Yeah, and then hit it, and then I'll go ahead and paste in the text from the script, and that way you'll have it ready to go. Okay, so this would only be if you've opened your Cyberbot template. Well, actually, any of you who opened the hex file, if you paste this in, it should work just fine too. The main characteristic of this file is that it has the Cyberbot module here in its project settings. So the project in the lower left, yeah, you've got the cyberbot.py module added from the homework. And then our main script is going to be this that I just pasted into the editor.
Okay.
And for any of you who had trouble downloading the hex file, if you were able to save a project from the homework that had that cyberbot.py module in it, then open that and then paste in the text that I just pasted in the chat.
I had a similar issue as Regina. I'm on a Mac though, but I had to click the reload button, and for some reason when I clicked that, it gave me the prompt to save the file. So I'm not sure.
Oh, wow. Okay, cool.
If she's seeing a reload button, but when I clicked that, it actually opened up the option to save it.
Okay, I'll try that.
Do you see a reload on yours?
I
Are we
download, but I
talking
don't-
about the reload by the web address in the upper?
Says mine said this page is not working and it's currently unable to handle this request, but then it's the reload option. When I click on that, it actually gave me the choice to save the file.
Okay, I'll try that.
So go ahead and load batteries into the battery pack.
I'll reload right here. Something happened. Yeah, I think that worked. Let's try that.
Yay.
Yay.
Boy, that was close. Excellent work, everyone.
Well, I had to do it 3 times. Oh, there's a reload right here. Let me try that.
Yeah, I was gonna say I did it about
Okay.
3 times, but
Yeah,
it
and I wasn't paying attention to the reload. And I was like, let me click on it, and it worked. Yes. Good,
yay,
good.
success. Woo, thank you.
You're
All
welcome.
right. And
Do you want one more question before maybe taking a break?
yeah, we'll go ahead and take another question. I would say though, get your batteries in, plug in the battery pack, set the 3-position switch to on, and then hit send to microbit. And what you want to see is there should be some blinky lights in the lower right corner of the Cyberbot board. And those lights that are alternating back and forth are telling you that essentially your whole system is up and running for the robot part of it, the Cyberbot board. And so we'll go ahead and take a 5-minute break, come back at 21 past the hour, and then we'll continue connecting. We'll make sure that we're all able to see that light blinking pattern, and then we'll connect and test our motors.
I'm going to pause the recording during the break in case someone would like to speak up who's been waiting for that.
Thank you, Stephanie. Okay, welcome back, everyone. So here we are. Most of us now have got our downloaded hex file running, or have, let's see. So we have one light that blinks left to right. Yes, that's right. You have, well, these are actually 2 different lights, and one is turning on while the other is off. And then they swap. So the other one that was off is now on, and the one is now off. And it alternates back and forth between that. And yes, the end effect is that it looks like one light is moving left and then right and then left and then right. And so I think we've got everybody who has either downloaded that file or been able to open the Cyberbot template that they created, and then upon sending to microbit, we get the little flashing light going back and forth. So if we've all got that going, so that LED is connected to pin 20 and 21. Yes, Alex, that's right. Pin 20 and 21, though, are pin 20 and 21 of this microcontroller right here, because this microcontroller on the microbit is talking with this microcontroller on the board, and it's pin 21 and pin 20 of this microcontroller that are right here. And then for building circuits, you have access to okay, so that's nice and clear. There's P0, P1, P2, and etc., all the way up to P15. And these are where you can plug in wires and jump to the breadboard. Then P20 is for a small piezo speaker, which for safety's sake, let's go ahead and insert underneath, because it might still have short pins that don't make it all the way through from the top. I'll loop back around to that. Because right now what I want to do is I want to make sure that everybody's servos are working. And what you'll be doing for that is you'll be connecting servo motors to P18 and P19. That's these ports right here. And these ports have power and ground to give each port has 3 pins. The lowest one is ground. That's the battery's negative terminal. Middle one is power. And then the upper one is on the far right, P19, and just next to the right is P18. And what we're going to do is find our servos. They look like this. And take each one out of the bag. Treat this little sub bag like it's made of gold. We're going to need these screws, these little screws right here. So save those little sub bags. Each sub bag has 2 screws and a little small wheel. So go ahead and take everything out of those little clear plastic baggies with the servo motor. And what I'm going to do is I'm going to plug these in and then I'll put up a diagram for it. What you want to do is make sure that these plugs here have 3 sockets to go on those 3 pins. And you want to make sure that the white wire is closest to the edge of the board. So see how you might be able to see that it says, waiting for the autofocus, you have a WRB next to those pins in the upper right, and we have a white, red, and black wire. So basically what we're going to do is we're going to slide the servo plug onto those 3 pins that are sticking up so that the pin that's closest to the edge goes to the white wire, the center pin goes to the red wire, and the bottom pin goes to the black wire. And we're going to do that for both the ports upstairs here labeled P18 and P19. And I'll switch over to a little diagram of that momentarily. Then there's one more item we'll have you dive into the box for, which are the robot wheels. They're in a bag that looks like this. There's 2 largish robot wheels. They look like this. And you can go ahead and slip those over the little output spline of the servo. This guy right here is where the wheel goes on to. So for a close-up of that wiring now, here is from the chapter. There's a little jumper that's between the two sets of servo ports that is already correctly set, so don't worry about that. Just pay attention to the wires and the plugs of the servos and make sure that they're slid down properly over the P18 and P19 ports with the white wire, the socket with the white wire coming out, going over the pin that's closest to the P18 label, and then below that red and below that black. And same with the P19 and the other servo. And then go ahead and give me a thumbs up when you've got it connected. My students have rechargeable batteries, so would I need to change it to VN? Yes. Yes, you would be using VN, and you can actually the particular flavor of servo we have in your kit will be fine with VN regardless. There's a little part where you identify your servo up here, and this is the particular servo you have, which is factory centered. Sometimes the Cyberbots come with the factory centered servos. Sometimes they come with a continuous rotation servo, and the students have to identify it. And if it's not factory centered, if it's this digital continuous rotation servo with the part number 900-08, then there's some additional steps where what you do is you run a script and you use a screwdriver. There's a little hole inside the servo. So after running the script, after connecting the servos and running the script, basically the servo will slowly turn, and you'll use a screwdriver to go through an adjusting hole in the servo and make the servo stop turning. And so we don't have to do that because all of our servos are the pre-centered ones. But if the students go through the identification procedure and they find that they have 900-0008 servos, or these are an older version of the servo, then they'll need to go and continue through connecting the servos and running this script to make the servo stay still, and then using a screwdriver through that adjusting hole to make it stay still. It says Parallax doesn't sell the non-centered servo ones anymore, right? No, we do. The ones that are not factory centered will come in the kit sometimes, other times they won't. So sometimes the kits will all have the factory centered servos. Sometimes they will have the servos that have to be manually centered once before you put the robot together. And thanks to the supply chain crisis, we had to go to this method of switching back and forth between different kinds of servos. And so we have the documentation for both. So Isaiah, you're using rechargeable batteries. That is fine. What we'll have you do then is, you know what? It's probably going to work just fine. But if we have any troubles, there's a little sleeve that's to the left of the P18 servo port. There's a little sleeve that's covering 2 pins. And by default, it covers the lower 2 pins, the center pin and the 5V pin. You'll want to pull that sleeve off and then slide it over the VN and center pin, the upper 2 pins. Okay, so next up, I'm going to I'll just in the interest of time, I'm going to go ahead and put in a script for you, as opposed to having you dig it out of the chapter. So bot of 20 servo underscore speed 50. And bear with me a second. Okay. I'd better test this before pasting it to you. Send to Cyberbot. Okay, so now the two servos are turning a little less than, they're turning at about a little less than half speed, and they're turning in opposite directions. So looks like this works. I'll go ahead and paste it into you. So go ahead and just paste this script over everything that you've got over your blinky lights right now. So Control A or Command A if you have a Mac, and then Control V or again Command V if you have a Mac, and that'll paste over it. Or you can just shade the whole thing, right click and select paste, and then hit send to microbit. And that should, if everything is working correctly, cause your wheels to start spinning in opposite directions. And go ahead and give me a thumbs up when you get that going. All right, way to go, Alex, Melissa, Rosanna, Miadi. I hope I said that right. Kyle, way to go, everybody. Okay,
Andy?
so yeah.
These servos don't have the screw on the servo spline, so you just press fit the wheel directly on it, correct?
They have well,
Or do you have
right
to
now
take a screw out?
we are saving, they don't have the screw pre-added to the servo spline, so we're not taking them apart. If you have the other kind of servos, it's
Yes.
true, you would be unscrewing a little cross-shaped that's called a servo horn.
And
For
yes,
these, we have to remember to save this little bag with the two screws and the little small
so
wheel.
the wheel just press fits on the servo spline. And then
For now.
could you zoom in on how the servos are plugged in? Yes, they do need to be plugged in to move.
Oh, yes,
So
absolutely.
you would have the power switch set to 0 while you plug them in. And then they plug
I
in.
forgot to say that. Yeah, you should have, we should have set the
Yes.
power to 0. Then we're plugging like so.
Mm-hmm.
I'll put
And
this in
also-
so you can actually look at it on the.
Yes, and you need to make sure that you've plugged into the correct two plugs, because there's two sets of plugs there. So if your servos aren't spinning, it could be a few things. It could be that the plugs are in backwards. It could be that you've plugged them into the wrong set, so the signals aren't going from the right IO pins mentioned in the code.
Like
Okay.
if you had plugged it into P16 and 17 by accident, we want to plug them into P18 and P19, which are to the right over here.
Could be that your battery pack is not plugged in, and it could be that your servo switch isn't slid all the way to 2, and it could also be that you have not yet actually put the code in the microbit that makes the servos move.
Man, I should have you teach these, Stephanie.
No. It's much easier to edit or critique.
All right, Isaiah.
Okay.
Oh, that's a good point. It should have stopped. it should have only gone for 4 seconds and then stopped. I don't know why it's still going. That none should have stopped it. Let's try 0. One, 2, 3, 4.
Hmm.
Oh. Oh, you know what? It's because I put it in while true. So it's stopping for an instant and then it's jumping back and resetting the speed again. Okay.
Yeah,
So let
okay.
me send y'all some corrected script.
And we still do have a few people for whom it's not working.
Okay. Now none should work. Capital great to stop it. I will test this first. Flash. 1, 2, 3, 4. Beautiful. So excellent question, Kyle. And here is the corrected script. I pasted it into the chat. And then Stephanie, you said that some folks Carolee not pasted. Oh, did I? No, it should be in there now.
I'm just checking with Carolee
Oh,
about
okay.
a couple of troubleshooting things.
Got it.
Not pasted.
Message unable to connect to the microbit. Okay. Let's see here. So probably the most common reason for being unable to connect to the microbit is if you have more than one editor tab open. And especially if that, okay, so like if I open another tab here, now I have 2 editor tabs open. And so if I hit send to microbit with 1 and connect, everything's great. And then I believe that if I try to do it with the other, no, it's okay. But if instead I had like some serial communication, like input type something, and I sent that to the microbit and then opened show serial, okay, that's going to really cause some trouble. Let's see, I'll reset the microbit to make sure it's displaying.
Yes, we have 2 people about position 2 versus position 1 on the switch. The wheels are not supposed to turn if the switch is in position 1. The purpose of that is to be able to program the microbit without having the robot run off the table unexpectedly.
Yeah, it's really nice because when you build sensor circuits on there, you can set it to position 1 and all the sensor circuits will work, but position 1 takes the motors out. And by the way, these are all in tutorials. So for example, if we go to learn.parallax.com, what I'm doing is I'm kind of going from memory and showing you what to do from the tutorials in the interest of time. But if we go to Cyberbot and then let's see here. So we are currently at it's kind of a subset of navigation. It's usually we do this after the robot's built. And so this is actually introduced in servo direction. And so what I'm doing is kind of the Cliff Notes version of that. And so here is a script where they set the P18 servo to -75. And you're welcome to try that. I'll go ahead and paste the web address and the script in. And you'll see that only 1 servo turns in that case. So that was the script. And then here is the web page that it's from. And if you're going sequentially. you and your students will have hit that page. And so what I want to do is experiment with the speed of the servo. So going back to, and then we have 15 minutes left. And so anybody who's having trouble getting this running, we'll go ahead and get you unstuck right after 5 o'clock Pacific. So at the after the top of the hour, we'll get you unstuck if you're still stuck. All right. So right now we had one turning 50 positive, which happens to be counterclockwise. And then the other turning 50 negative. What happens if you make that 100 positive and 100 negative? What do you get? On my end, I get servos that are turning roughly twice as fast as they were. And
How fast are they capable of going?
I'm sorry?
How fast? What should be the fastest we put in? Like that would be, I'll probably not go over it.
Oh, okay. So basically this little diagram right here is maybe a little bit tough to read at first, but let me take you through it. 25 is where you can be pretty sure the servo is going to move slowly. And as you increase, it's going to go faster in the counterclockwise direction. And once you get to about 125, 130, that's as fast as it's going to go. And anything higher than that, we just consider to be overdrive. And we don't typically ask it for anything more than plus and minus 200. And basically often we'll just lazily set it to plus and minus 200, basically telling the servo motors, give us everything you got. But if you want to have some speed control, or if the bot's curving a little bit and you want to straighten it out, the place to start straightening it out would be plus and minus 125. And then you could reduce the speed of a faster wheel. Let's say that one wheel's going too fast. Well, that wheel, you might try 115 or 110 or 100, and that'll slow it down to match with the faster wheel if the robot's curving a little bit. So yeah, linear speed control, that being, if you increase the value like 50, here we are at 50, if we cut that 50 in half, so here we are at 50 and we're getting about 30 RPMs out of it. Okay, so we cut it in half and give it 25 instead. Well, gee, now we're getting maybe 10 or 15 RPMs out of it. If we up it to say 150, we'll maybe get 50 RPMs out of it. And that'll vary. I think we're going to be a lot closer to, I think the speeds that you're going to see with the servos you have are going to be a little bit higher than this. You're going to see 60 RPMs as your top speed. So, so go ahead and try that. So for example, you could start with just 25 and 25 on both servos. And now they should both spin slowly counterclockwise for 4 seconds. Then try negative 25 and negative 25. And then you want to see the servos spin slowly clockwise. And then try upping it to 50. And if they're still negative, it's going to go clockwise. Oopsie, I saved. Send to microbit. So now they're going twice as fast as they were, roughly. And if you do positive 50, they'll go counterclockwise, again at the same speed. And you can try 75, 100, and 125, both plus and minus. And you'll see that every time you use plus, it's going to go counterclockwise. Every time you use minus, it'll go clockwise. And the greater the absolute value, like plus or minus 125 would be roughly top speed, plus or minus 100 would be roughly 3/4 speed, and so on. Played with the numbers and is still working. Good. Why are we using negative numbers to go clockwise? Well, there's this thing in physics and engineering called the right-hand rule. And the right-hand rule is kind of the way faucets work, where if you turn it clockwise, it's going to close everything down. And if you turn it or like with a screwdriver and a screw, if you turn it clockwise, it'll go into the thing. And if you turn it counterclockwise, it'll come back out. And with the right-hand rule in math, physics, and engineering, we use positive values for counterclockwise usually and negative values for clockwise.
That's the same in math too, because I'm a high school math teacher, and then on the coordinate grid, -90 is clockwise and +90 is counter.
Yes, very good point. Very good point. Yes, on the Cartesian plane, we have plotting of angles, which I'm not going to take the time to do it now, but we have some cool little lessons on that as well, and how it maps to devices that measure angle and determine angle. It's another kit, but it's kind of fun stuff. All right, so this is great. If we've all got this going and we're all clear that a negative value will give you clockwise rotation, and a negative larger value will give you faster clockwise rotation, and that a positive value will give you counterclockwise, and a larger positive value will give you faster counterclockwise. That's the really important lesson here, and we're ready to put our robots together. So what that does is it brings us to our homework. And for any of you who didn't have time to do it all, do try all those speeds, plus or minus 25, plus or minus 50, plus or minus 75, 100, and 125, just to kind of get a feel for that wheel speed and direction. And in the textbook, it also talks about pulses. We skipped over building a circuit and turning a light on and off. And essentially, the idea is that if you could look at a light at 50 times a second, that light would stay on for a certain amount of time, 1.5 thousandth of a second to make things stay still. For full speed clockwise, it would be 1.3 thousandths of a second, and for full speed counterclockwise, it would be 1.7 thousandths of a second. And so that plus or minus 200 for max speed overdrive of the servo is basically 200 microseconds or 200 millionths of a second greater than 1.5 thousandths of a second. And then it's repeated every 20 thousandths of a second, that signal. And so that's what's going on under the hood. We skipped over lights. I'll try to loop back and show you where the lights and the speakers and the other fun stuff, just learning about circuits before diving into this, is covered. For your homework, we are going to have you, this is an inventory of the parts that you're going to need. And let's see here. A heads up, we recommend that when you put the servo in the chassis, the output spline goes closer to the center of the chassis, not all the way to the front like this. The reason this makes turning work better. So output splines to the center of the chassis. you'll want to make sure to unplug the power between now and the next time that you use your Cyberbot. So I'm going to switch over, maximize, whoopsie, I maximized the wrong thing. Maximize. So when not in use, set the power switch to 0. That's all the way to the left. And unplug the barrel plug from the barrel jack. That way there won't be any power going to the microbit that you're not expecting. Now you'll also need to unplug the USB, but I'm less concerned about that. I just want to make sure that everybody's batteries don't get drained between now and Wednesday. And then here's the USB. You would unplug that when leaving it unattended. You can actually, it's okay to pull it out of the Cyberbot board, but you can also just leave it in the Cyberbot board. And when unplugging, I usually just hold it with my thumb against the microbit here. And that way I'm unplugging the USB and not unplugging the microbit from the socket. If it so happens that the USB is a tighter fit than the microbit is from the socket. Okay, so for homework, we are going to have you follow these links, and I'll go ahead and email them to you.
Could you linger on that unplug slide
Okay.
for a moment longer?
Unplug power when you are done this one.
Yes, that one.
Okay.
Bears repeating.
Yes, somebody cited that students, not all students will have it sink in unless you say it 3 times. So unplug power when you are done. Unplug power when you are done. Unplug power when you are done.
Thank you.
Just make sure you're not saying Beetlejuice.
Very true.
I'm sorry, did you say unplug power when you were done?
Thank you. Yes, I did.
That's what the students will say. Is that what she said?
Well, thank you for the demonstration. All righty. For homework, we're going to have you put together the Cyberbot. Now, remember, when you're putting together the Cyberbot, have the servo output spline coming out closer to the center of the robot, not in the front. I said that 3 times. No, I didn't. I only said it 2. Output spline towards the center of the robot, not to the front. Unplug power. And then just follow the instructions for building the robot. You will, when installing the servos, come across that, that idea of putting the servo in so that the output spline is near the center of the robot. It could alternately be towards the front, but we don't want that. And so these are going to be step-by-step instructions that you'll be following. Here's the part where the battery pack is done. I'm kind of a little forward here. Build the chassis, take an inventory of all your parts, then hit the next page. We're going to add a couple of things to the top of the board, then go to the next page. This is where we find our servos. You won't have to take it apart as shown here. It's already taken apart. And then we'll be putting the servos on. And then I want to bring one other thing to your attention about this. And that is, as you're following the instructions, when you get to where you're putting on the wheels, okay, there are some screws that are going to attach the wheel to the output spline. Whoopsie. Get over to. Okay, when you put the wheel on the output spline like that, after putting it on the chassis, that's where these little tiny bags that came with the servo come in. You have 1 screw and a spare. Be very gentle with the screwdriver when you're attaching the wheel to the servo. You'll use a parallax screwdriver that resembles this, that's going to come in your kit, and basically you want to just only finger tighten that, that screw. So see if I can get a good shot of it. So here I am tightening the screw, and you want it to go down mostly flush with the wheel. But once you feel it start to resist, that's all you want to tighten it. Just with your very fingertips. When you feel it start to resist tightening the screwdriver anymore, then you know it's tightened. And again, that's a step that's after you've put the servos, after you've attached them to the chassis. You're using these plastic screws to attach the wheel to the servo spline. So be very gentle in that step. And then last but not least, homework wise, we're also going to send you an email probably tomorrow, Stephanie, do you think?
Yeah,
well,
that sounds right.
Yeah, we'll send out an email letting you know if you've already joined learn.parallax.com in the past, just go and log in. And the link will be in the email. It's this one right here. And just make sure you can log in is all. This is not going to affect your ability to participate. So if there's some kind of gotcha, like you're unable to get a recovery email and you don't remember your password, don't stress about it. It's fine. But do your best to get logged in. But again, don't worry if you can't get it done. If you have not been part of learn.parallax.com, if you have not signed up, Stephanie will sign you up and send you an email letting you know you've been signed up with some instructions on what to do your first time to learn.parallax.com. This will give you access to the teacher materials, which we'll again be talking about on Wednesday. And then another set of teacher materials that we want you to access. Same thing, if you're already signed up at cyber.org, then just make sure you can log in. If you've never logged in, first of all, sign up with this link. And then after you get confirmation from them, sign in. And again, if you don't, if you're not able to get that done by Wednesday, don't worry, because this is all just show and tell, but it's going to be important because these are all for teacher resources. So sometime between now and say next week, you'll definitely want to be able to log into both sites. And it is 5:04. Sorry, I took you a little over. That's all I had to say for today. And we'll look forward to seeing you Wednesday, same time, same link to join. And keep an eye open for your homework. I'll also send links to the video recording of this and the chat log. You can download both of those. And have a great rest of your day, everyone. And anybody who wants to stick around and get some additional tech support or just talk, ask questions, etc., we're going to stop the recording and then we'll go ahead and have some open discussion. Thanks for coming. We'll see you Wednesday.
Thank you, guys.